Let's get started with our next session here. Jonathan is going to come on board and talk to us a little bit about exfiltration paths using some of those internal VPC endpoints or private link endpoints, depending on which cloud provider you're playing with. This is a topic, I've heard this talked about a lot from a blue team perspective, where we want to use these to kind of get our traffic routing internally through VPCs so it doesn't traverse the internet. I'm really excited to hear the perspective, maybe from a more of a red team perspective on how to maybe abuse some of these things a little bit. So Jonathan, without further ado, welcome. Thanks for joining us, and I'll pass it over to you to take us on the journey here.
Thank you very much for the introduction, Eric, and thank you for having me. So, hi everyone, and welcome to my talk, Exfiltration Paths in Isolated Environments Using VPC Endpoints. I'm Jonathan Adler, a security consultant at F-Secure Consulting and a member of our global cloud security team. So I'm sure that we're all aware of the most prevalent ways in which cloud environments are compromised and the data within those environments leak to the public, whether it's through S3 buckets or some exposed database, or leaked access keys that an attacker uses to then obtain some sensitive data. But having worked with global financial organizations, their primary concern is obviously to safeguard their customers' data. And as we'll see, VPC endpoints provides some of that assurance by limiting their data's exposure to the internet. However, if these VPC endpoints are misconfigured, then there's a significant unintended risk that, in my experience, is not well understood. And what we'll do today is to highlight these misconfigurations with real-world examples to raise the awareness and hopefully improve all of our cloud security posture. So we'll start by defining what we mean by an isolated environment, and then we'll introduce VPC endpoints, what they are, and how they play an important role in building these types of environments. Next, we'll look at a case study of an isolated environment that I encountered through one of my engagements, and we'll look at how I managed to leverage 3 different exfiltration paths through that environment to obtain sensitive information. We'll briefly talk about detection and the telemetry sources that can help us identify these exfiltration attacks. And then finally, we'll discuss how to discover these vulnerable endpoints within your AWS estate and what you can do to prevent them from being used for exfiltration. So with that, let's get started. So what's an isolated environment? Well, I think the first thing we need to do is, if we look at the typical corporate network on premises, they're usually quite locked down, meaning that the employees, developers, operations can only access resources on the internet through some type of an on-premises proxy. And with regards to entering that corporate network, you usually have to use some type of a remote access solution, whether it's a VPN or something along those lines. And in addition to that, usually these corporations restrict access to their cloud environments, in this case AWS, by requiring that their employees go through some type of a custom proxy on premises. So they don't have direct access to the cloud environment. And if we then look at the cloud, specifically to AWS, these banks and large organizations usually apply the same design principle as they do on premises to the cloud. Again, the goal here is to keep the cloud environment isolated from other tenants and also from the public internet, specifically the data being exposed to the public internet. So effectively what they're doing is extended their on-premises network into the cloud, and then taking advantage of the elasticity that the cloud brings. So let's have a look at what this looks like if we were to build this environment on AWS. So the first thing that we would do is we'd create a VPC without an internet gateway. The internet gateway is what would provide inbound access into our VPC from the internet, and also from that VPC out to the internet, which we're not interested in doing. Within this VPC, we create a subnet, which just has a single route to the VPC CIDR within our local route table. And then we deploy some EC2 instance or other resources that are running a sensitive workload. So in this case, it's going to be an internal banking application used by employees on the on-premises network. But our employees obviously want to access this application. So the way that we facilitate that is using a VPN gateway in this case, or you could use Direct Connect. And then this EC2 instance running some type of application obviously wants to access, let's say, a secret and secrets manager, wants to send some application logs into CloudWatch logs, and wants to get some operating system updates from Amazon S3. So the way that we facilitate that is by creating these VPC endpoints, which we're going to discuss in just a moment. One final thing here to point out is that there's also this AWS provided DNS within this environment. And the way that we sort of prevent exfiltration through DNS, which we're not going to focus on, but just as a quick note, we can use the recent introduction of this DNS firewall and essentially restrict resolution to only the AWS Amazon.com subdomains, which is what would be required for our EC2 instance to access each of these AWS services. So what we've done here is essentially created an environment that has some controlled paths into the environment. In this case, we have the one from on-premises, and then we have several paths out of our environment to these Amazon services. The next thing that we would do, which is very similar to on-premises, is that we implement some network access controls. So in this case, we introduce some network access control lists on this VPC that allow only, in this case, HTTPS into the environment and HTTPS to out of the environment to these three Amazon services, since its NACLs are stateless. And on our EC2 instance, we create a security group that only allows inbound access from the VPN gateway and outbound access to these three endpoints. So that's our lockdown or isolated environment. But the question here is it really as isolated as we think that it is? And what are these VPC endpoints? So to understand VPC endpoints, the first thing we need to do is to understand how our EC2 instance and the application running on that instance would access these three Amazon services. So as I mentioned previously, what we would do is we would create an internet gateway, and that gateway would facilitate our EC2 instance being able to access these three services by traversing the public internet. But if we revisit our definition of an isolated environment, traversing the public internet is undesirable because it exposes or potentially exposes our data to being leaked. So what we can do is we create these VPC endpoints, and these endpoints essentially allow us to contain this network traffic to these AWS services within the AWS environment. So traffic to any of these services never leaves the Amazon backbone. So in this case, we have an endpoint that it's actually supposed to be an interface endpoint here with the wrong icon, but that's fine. And what this endpoint is allowing the EC2 instance to do is to access Secrets Manager. If we then want to access the CloudWatch service, we would need to create another interface endpoint. And similarly, if we want to access the S3 service, we would create a gateway endpoint. Now, you might be wondering, what is the main difference between these interface endpoints and gateway endpoints? And essentially, for our discussion here, they're very similar. The main difference is that an interface endpoint is tied to a network interface within your subnet, and the gateway endpoint is tied to a route within your VPC's route table. So now that we have, or I should point out one more thing here, and that is you might be wondering, the application that you've deployed on your EC2 instance, how is that able to resolve whether it's going to go through the internet gateway or access these VPC endpoints? And basically the AWS CLI and the SDKs automatically resolve the endpoint within the specific region. So in this case, for the EC2 instance to access secrets manager, it would access the secret manager.eu-west1.amazonaws.com. So in terms of your application itself, you don't need to make any changes to it as long as you're allowing DNS resolution to these Amazon services. And to my point here, now that our EC2 instance can access these services without traversing the public internet, there's no need for the internet gateway. At the current time, 79 Amazon services support endpoints, and of those, 23 don't support endpoint policies, which is going to be the main discussion point going forward. And what I mean by that is that each of these endpoints, whether interface or gateway endpoints, have a endpoint policy or a resource policy. And it's what we can see here on this slide. So by default, if you don't create one yourself, Amazon will attach one that, as we can see here, allows any action to any resource by any principal. And we'll get to why this is an issue in a moment. So looking at a case study involving an engagement that I did for a large global financial organization. This is the same diagram that we looked at earlier, where we have this sensitive workload running on an EC2 instance, what I call here an application server. And this instance needs access to these various services. So our employees, again, access the application server through a VPN gateway. And then the EC2 instance itself accesses each of these three services through these VPC endpoints. What we are concerned with here is that if an attacker was to compromise the on-premises network and then pivot into the cloud environment, which is a likely scenario just because we mentioned earlier that the on-premises network is fairly restricted in terms of outbound access through a proxy and also inbound access into the environment. So let's say that the attacker is compromised on-premises network. They might then try to pivot into the bank's cloud environment and see whether it would be easier to exfiltrate data through that environment. So looking at our first exfiltration path using Secrets Manager. So we're going to look first what it looks like on the operational level, like day-to-day use, and then we're going to look at how an attacker would leverage the specific misconfigurations to exfiltrate data. And I'll just make it easier for us to understand what's going on. So here we have our EC2 instance, and it needs to access a secret, for instance, an API key within Secrets Manager. So if we have a look at the instance's instance profile, we can see here that it's a good profile in terms of it being restricted to one specific action, which is to get a secret value, and the resource that it can get is this one specific API key. If we look at the endpoint policy, this is the default policy attached by Amazon because we have not created our own. So the EC2 instance is then able to obtain or get this API key. So you might be wondering, how does an attacker who has compromised this EC2 instance leverage this misconfiguration? So what we have here is we have the bank's Amazon account on the left, and we have the attacker's account on the right. And our attacker, if you recall earlier, has pivoted from the on-premises network into this isolated environment and is on this EC2 instance. So the attacker, the way we're going to exfiltrate some sensitive data within this environment is by getting a secret within the attacker's account. So the EC2 instance, we already know, is very restricted and won't allow that. So what we'll do is we'll create an IAM user with the following IAM policy, which just allows us to get a secret value for any resource. And we then take those access keys and we put them on the compromised EC2 instance. Still on that EC2 instance, we've exported our access key and our secret access key. And then we're going to assume that the AWS CLI is on this instance because the instance is running AWS Linux. And we're going to run this command, AWS Secrets Manager, get secret value, with a secret ID of customer account numbers, which is the bit of sensitive information we want to exfiltrate from this environment. Because this particular secret, customer account numbers, doesn't exist within the attacker's account, we're going to get this error message that resource not found. But if we have a look at the CloudTrail logs within the attacker account, we can see here that the secret ID we tried to get has been logged. And so we have now exfiltrated the customer-account-numbers sensitive data. So you might be wondering how much data can you actually exfiltrate from using this method, and the secret ID can be a maximum of 2048 characters. So moving on to the second exfiltration path, and this time using CloudWatch logs. This is very similar to the one we just saw with Secrets Manager. We have our EC2 instance with a very restrictive instance role, only allows one specific action, which is to, in this case, the instance is going to put some application logs into the bank's CloudWatch group called app-server-logs. And we have the same default VPC endpoint policy. So the instance then pushes those logs into CloudWatch logs. Looking at the attacker view, again, we've compromised this EC2 instance, pivoting from on-prem. And the question is now, how do we leverage this misconfiguration to exfiltrate some data? So same as before, we create our IAM user with the permission to put log events into the attacker account's CloudWatch logs. We transfer those access keys to the EC2 instance. And then here we're using the AWS CLI again to put the log events into the attacker log group, into the attacker log stream with this bit of JSON, which is the data we want to exfiltrate. So the important part here is the message, which can be up to 1 megabyte. So compared to Secrets Manager, we're able to exfiltrate more information in one go. So it seems, there we go, slight delay. So now looking at the attacker's account, specifically that CloudWatch log group, we can see here that there is a blob of base64 encoded information. So that's the data that we exfiltrated from the bank's environment. Moving on to the final and probably my favorite exfiltration path using S3. So this one is slightly different in that our EC2 instance in this case has an instance profile that is perhaps a bit more permissive than before. We still can only get an object within our S3 bucket, but we can get object in any S3 bucket. And again, the purpose here is that we're running AWS Linux, and we want to get the updates to the yum packages from Amazon's hosted S3 bucket within the region. Looking at the endpoint policy for this S3 gateway endpoint, we can see here that in this case, the endpoint policy is actually a custom one, and it is, on the face of it, more restrictive than the default one we saw earlier. So the endpoint allows us to get an S3 object, and we can only do that to a resource that has a bucket name amazonlinux.wildcard.amazonaws.com. And we'll see in just a moment why this is not as restrictive as we would like. So we're now able to get some updates. And clearly this instance hasn't been updated in a while, so lots of updates. So looking from the attacker perspective, again, our attacker is on this compromised EC2 instance within the bank's isolated environment. And in our attacker account, what's different from the other two exfiltration paths we saw is that this time around, we don't actually have to create an IAM user and some access keys, and then transfer those access keys into this compromised instance, which is nice because it just means that it's one less artifact that we're kind of leaving on this compromised instance. So there is a potential that this makes it a little bit trickier for the blue team to identify this attack. So what we have in the attacker count is we have CloudTrail logs, specifically data events for S3 enabled, which will allow us to record any events within our bucket. And what we do is we create an S3 bucket and attach a bucket policy, making it public. And that's an important note. That's why we don't need any access keys here. This is a public bucket that anybody could try and request objects from. But that doesn't really matter for our particular use case here. So the bucket name, as you can see, is amazonlinux.cloudsecnext2021.amazonaws.com. And if we then, on this compromised instance, again, using the AWS CLI, we're able to try and retrieve an object with the key customer-account-number. And we can see access denied because this particular object doesn't actually exist in our attacker bucket. But it doesn't need to because, as we'll see, that event is still recorded. So if we, excuse me, if we then use Athena to query our CloudTrail logs, specifically looking in our attacker account for any error code access denied on this specific bucket, we will see that we have these three pieces of information that we have exfiltrated from the bank's account. So customer account number, hello friend, and CloudSecNext 2021. And one other thing to note here that makes this interesting, or this particular exfiltration path interesting, is that although we have assumed that the Amazon CLI is available on this compromised instance, it would be entirely possible to perform this exfiltration using curl if that was allowed on the instance, because this is just a very simple HTTP request to the Amazon API within the attacker's account. And we don't need any access keys or signing of our request or anything like that. So let's have a brief discussion about detection and what telemetry sources could be useful if we suspect that our VPC endpoints have been used for exfiltration. So we have AWS CloudTrail, which you should definitely have enabled within your organization as an organization trail, but it only records events on the control plane. So things such as create instance, create bucket, or destroy an instance or bucket. It's not going to record any network events through a VPC endpoint. So definitely enable it, but it's not going to help us investigate this exfiltration. GuardDuty is a threat monitoring service provided by AWS, which has a series of rules created by the Amazon security team that they constantly update. And it has access to various log sources, CloudTrail, flow logs, DNS logs, and so on. But again, it doesn't actually currently have a detection use case that would trigger or that would alert us to this exfiltration. And then we have VPC flow logs, which, as the name sounds, actually does record network events. And it's questionable as to how useful these are. In my testing, it's non-trivial to actually use these logs to be able to identify exfiltration through VPC endpoints. But I'm sure that with some more work, it could be possible to use them for that. If we then move on to prevention, in the cloud, arguably, prevention is more important than detection, especially considering that attackers can automate their attacks just like we can automate the provisioning of resources. So whenever possible, we want to implement security controls that will prevent malicious actions within our AWS environment. So the first thing that we need to do before we can implement any preventative control is that we need to identify any VPC endpoints within our environment that are vulnerable to the exfiltration paths that we've just looked at. And as we can see here, using this short bash script and the AWS CLI, we can describe the VPC endpoints within all of our regions within a specific AWS account. And then if we look at the output of that, we will get this large JSON blob where each VPC endpoint we'll also have the endpoint policy or policy document in this case, showing whether it's a permissive policy or not. And then from there, we can look at hardening these policies. So if we have a look at what does a hardened policy actually look like, here we have on the left the policy, and then on the right we have our diagram. So let's quickly step through this and see how this policy would prevent exfiltration to an attacker-controlled S3 bucket. So we have this trusted principal, this EC2 instance running in our trusted account, the bank account, using the example from earlier. And that EC2 instance is allowed to get an object in an S3 bucket within our trusted account using this condition S3 resource account, which essentially means that our trusted principal is allowed to get an object within any S3 bucket in the trusted account. So we're not interested at this moment on limiting what buckets in the trusted account the trusted principal can access. We're just interested in making sure that it can't access buckets in an untrusted or attacker-controlled account. So this is what this policy allows. And at the same time, this policy denies the trusted principal from accessing an S3 bucket in our non-trusted account. And using the example earlier where we could transfer some access keys that would allow this EC2 instance to make requests to our attacker-controlled account. Again, that is also denied to both the trusted resource and also an bucket in our attacker-controlled account. So to summarize what we've discussed and the key takeaways, we've discussed isolated environments and how VPC endpoints are a useful construct in creating those environments. We've highlighted how misconfigured VPC endpoints can be, that misconfiguration can be leveraged by attackers to exfiltrate data from your environment, going through 3 different real-world examples. And then we briefly touched upon what telemetry sources could be useful in an investigation. But as we discussed, it's non-trivial to actually detect this type of exfiltration. And then we discussed prevention, in that how you would inventory the VPC endpoints within your environment and make sure that those VPC endpoints have a custom policy that is restrictive, basically only allowing access to resources within the endpoint's own AWS account, as opposed to an attacker-controlled account. So with that, if you take away anything from this talk, please go and review your endpoint policies in your AWS estate and make sure that the data within your environment is secure. So have fun, and thank you very much for having me. Thank you to the organizers, and just a special shout out to my colleague Mohit, who was the first one to actually get me excited about VPC endpoints and showing me how to do bad things with them. Thank you very much.
That was awesome. Really good demo or kind of walkthrough of how that works. We've got a couple questions out there. One, just to confirm, so Chris mentioned this in the Slack workspace. You're actually able to create a bucket that ends with AmazonAWS.com?
Yeah, correct. So I was a bit surprised by that as well, but there are no restrictions as to what you can name a bucket. It has to be unique within the whole namespace. But yes, I was able to do that. So Amazon within their documentation actually show that you could specify, if I go back here, that you can actually specify the region where this bucket is located. So again, the purpose of this was to get updates for Amazon Linux. So where we have this wildcard here, you could actually put the region, so EU West 1 in this particular case, or another region. But they also show examples where you just put the wildcard. And so if no one else has created a bucket that satisfies this resource ARN, then you as an attacker could go ahead and just claim it. Just like you could for apple.com if Apple don't have a bucket and that type of thing.
Yeah, that's a nice little kind of almost DNS hijacking example there, kind of at the same time. That's pretty awesome. Let's see, we've got a couple other questions here. So Roberto in the Zoom chat said, from your experience, how frequent are these misconfigurations, and how often do you think the exfiltration side would be successful?
That's, that's a great question. It's obviously difficult to say how pervasive these misconfigurations are. If I just speak to my own experience working with the clients that I do and my colleagues, I would say that even if you are, let's say, an organization that is fairly cloud mature, I have actually spotted these misconfigurations within those environments. So I think that all of us are very aware of, misconfigured S3 buckets leading to exposed sensitive data and databases on these types of things. But again, the purpose here was to highlight something that I feel perhaps doesn't get as much attention. And it might be that um, when you show what the business impact is, that's when people kind of start to pay attention. So yeah, it's difficult to say exactly how, whether these VPC endpoints are used for exfiltration in the wild. I can't really speak to that.
Yeah. Well, I haven't looked recently, but I'm already seeing a PACU module in flight here for exfiltrating data through VPC endpoints in a more automated fashion. So that will probably be on their radar if it's not already.
Yeah, definitely. I think that there is probably an opportunity here to create some tooling because, again, we've now looked at this from the perspective that we actually can see what the misconfiguration is and then see how to leverage that misconfiguration to exfiltrate the data. But if you are performing, let's say, a red team exercise, or you are a real attacker where you don't have the knowledge of the environment itself, so you can actually see these misconfigurations, I would say that uh, trying to identify whether you can exfiltrate through VPC endpoint is not going to be as easy as if you can actually see the whole configuration of the environment.
For sure. Yeah, it's definitely something, we push people to use these. It's unfortunate that of course, the default policy puts you in a interesting state there, right?
Yeah, it would be nice if Amazon perhaps took the approach that they do with IAM, where by default you deny everything unless you give a user specific permissions. So when you create a VPC endpoint, it'd be nice if the default policy was already restricted to resources within your account, and I think that would go a long way to securing these environments.
Yeah, I'd be curious. Do you know off the top of your head? I suspect these policies are not included in their kind of IAM access analyzer checks either.
That's a great question. I honestly haven't had a look, so I will definitely take a look after this to see if that analyzer would spot this.
Yeah, be interesting. My gut says it's mostly user and role policies. I doubt it, but
I think so as well. Yeah, since we're talking about the resource policies here as opposed to identity-based ones, I'm assuming that the analyzer focuses more on identity, uh, as it should, right? But it would be nice perhaps if it had the functionality to look at resource-based policies as well.
yeah, absolutely. Ben had one other question on the Slack channel. Well, we've got another minute or two here.
Sure.
So on the S3 side, would you follow the same approach, or what approach would you take to lock down exfiltrating to that public S3 bucket?
So great question. I think that if I just quickly go back to the slide here, this example here with this endpoint policy, specifically this condition down here, the S3 resource account condition, which is fairly new. I think Amazon introduced it, I think December last year. This specifically allows access to only S3 buckets within this account. So by applying a policy similar to this, at least with this condition, you would not be able to perform the exfiltration attack that we looked at earlier. And I guess we should note here as well that because we were talking about updates to the AWS Linux operating system, and it's an AWS hosted S3 bucket, obviously we wouldn't be able to use this condition. So I think the best thing here would just be to specify a resource ARN that has the region within the bucket name, so that there are no wildcards and an attacker can take advantage of registering a bucket that meets that resource ARN.
Makes sense. It's kind of where my head went to. We were commenting in the Slack channel, just wild cards
Yeah.
everywhere, right?
Yeah, exactly. We don't really like to see those, but uh, applying least privilege to IAM is not an easy thing. There are lots of tools to help, but I see it all the time where organizations are having that difficulty between, what permissions do users need or developers need, and developers want more permissions. So IAM is arguably the most critical thing to get right in the cloud, and also the hardest.
I 100% agree. That's a perfect closing comment for us. Just great examples of where this can continue to kind of bite us in the, especially in the AWS ecosystem.
Yeah, and just as a final note as well, we've focused on AWS here, but I believe that there's a similar kind of construct to VPC endpoint, both within Azure and possibly GCP. So if anyone's interested in looking into that and seeing whether, by default, could you perform these types of exfiltration attacks or not, I'd be interested in seeing that.
Yeah, we'll get a hold of you about a year from now for the next event. We can talk about it on the Azure side.
Sounds awesome. Thank you so much for having me.
Yeah, thank you for presenting this really cool research, Jonathan. So we'll head out into the Slack workspace and we can continue the conversation over there.
Definitely. Yeah, looking forward to answering any questions that we can uncover during this talk.
All right. Thank you again.